Hey guys, welcome back to my channel and I hope you are all doing extremely well. And this is lecture 7 on linked list series. So in this lecture we are going to cover one of the important problem from lead code, and this problem is a medium level, and I highly recommend you to please watch from lecture 1 till whatever I'm going to post in future, so that I believe you are going to learn a lot of things in this series, and I believe you are going to be very strong in solving the linked list problem. Without further delay, let's get started with today's problem. So the problem number is to add two number. So we will be given two lists, okay, in the reverse order, and we need to add those two and we need to return the new list. If we carefully observe, 2 plus 5 is 7, 4 plus 6 is 10, but carry is going to be 1. So 0 I am adding here and 1 is going to be here. 1 plus 3, 4, 4 plus 4 is 8. So this is how my output is. Let me go to the diagram for a better understanding. So here is, so if your list L1, assume, is something like this: 1, 2, 3, and your L2 is something like this: 4, 5, and 6. If this is the case, so these are already in reverse order. Reverse order. Okay, what I mean by that. So if this is reverse order, what is the correct order is going to be? 3, 2, 1. Right? If this is the reverse order, what is the correct order is going to be? 6, 5, 4. So how we generally do the addition? 1 plus 4 is 5, 2 plus 5 is 7, 3 plus 6 is 9. Okay, and your output also going to be in reverse order, right? So that means your output is going to be 5, 7, 9. Okay, now let's try to add this in the same order how they are given. So 1 plus 4 is nothing but 5, 2 plus 5 is nothing but 7, 3 plus 6 is nothing but 9, and 9 next is going to be null. So this is how we need to return our output. I hope you got the problem statement. Let's see how we can solve this problem. I am taking the same input as example: 1, 2, 3. This is L1 list 1, and next is going to be 4, 5, 6. Okay, this is L2. So we are going to solve this with the help of carry. Okay, we are going to have a carry. Initial value is going to be 0. Okay, I can tell you the purpose of this variable. First I start iterating from first node of the L1 and first node of the L2, and I can check one thing. So 1 plus 4 is nothing but 5. If it is greater than 9, then I need to perform the division and I need to uh, change the carry value. Okay, but here 1 plus 4 is nothing but 5. Then I mean to say, I created a new node with a 5. Then its next is initially going to be null. Okay, assume this is my current. Okay, next 2 plus 5 is 7. Okay, then what I'm going to do here is, so 7 is not greater than 9. Okay, then I no need to worry about a carry here. Okay, then 7, but current is pointing to here. So what I'm going to do, current dot next is going to be 7, and then immediately I'm going to change the current pointer. Okay, and 7's next is going to be null. Then 3 plus 6 is 9. So 9 greater than 9 is not correct. I mean, it is false. Then 7's next is going to be 9. Then this is going to be my current. So initially head will be pointing to here. Okay, then we are going to return our head. Then it is going to return output something like this. So this is a happy flow. Okay, so where we not changing the carry. Okay, let me go and take another example. Okay, which is there in our example: 2, 4, 3, 5, 6, 4. Okay, the L1 is 2, 4, 3, 5, 6, 4. Okay, initially the carry I'm denoting with C here, carry is 0. Okay, as usual, this is L1, this is L2. So what I'm going to do here is, so first I'm going to create a node of these two values, 2 plus 5, 7. Okay, 7 next is null and current is pointing to here, head also pointing to this one. Okay, now 7 next is null anyhow. Okay, now what I'm going to do here is 4 plus 6 is nothing but what? 10. That means I need to create a node with a 0 and I need to forward this carry to the next addition. So what I'm going to do here is carry is equal to sum divided by 10. So what it is going to return me? It is going to be written 1. So sum is going to be sum modulos 10. Okay, then what is sum here? 10. 10 more 10 is what? 0. So I am going to insert 0 here and I'm going to send my carry to here. Okay, then zeros next is initially null and I'm going to update my curve pointer. Okay, now what is going to happen? 1 plus 3 is 4, 4 plus 4 is 8, which is not greater than 9. Then I'm going to insert it as usual and my curve is going to point here and 8 next is going to be null. Okay, so the only thing we have to keep in mind is how we are going to calculate this sum, this carry and sum. And let me tell you, so how this sum is going to be every time. So initially carry is 0, right? So sum formula is going to be L1 dot val, this is here, okay, plus L2 dot val plus C. L2 dot val is this, C is initially 0. So 2 plus 5 plus 0. So this is what your sum is going to be every time, because here in this case 4 plus 6 is 10. So you created a node with 0 and you passed 1 as a carry, but you need to include that also for the next sum, right? So there might be a chance if this is here is 6. Okay, let's assume. So 1 plus 6 is 7. 7 plus 4 is again 10. Sorry, 11. Okay, then you need to carry forward one time carry. Okay, then that is the case. So every time you need to include your carry followed by your sum, I mean L1 value followed by your L2 value. Okay, this is all about the problem statement. So what is the time and space complexity, sir? The time complexity is going to be big O of n plus m. Okay, where n is the length of L1, m is the length of L2, and the space complexity is going to be big O of n. Here we are going to create a brand new list, okay, to form this output. Okay, and I hope you understood the intuition behind this problem. Let's get into the coding part. Here is I am. So what is the first and foremost condition? Let's try to understand the nodes in the linked list. So they are saying a number of nodes in the each linked list carries from 1 to 100. Great. So now let's try to take something. Int carry is equal to 0 initially. So while L1 not equal to null or L2 not equal to null. Okay. So till this condition satisfies, one second. Till this condition satisfy, I need to perform some operation because there is a valid value either in L1 or else either in L2. The first is we need to grab the value of L1 or else L2 and L2. Val1 is nothing but if L1 not equal to null, L1, if L1 not equal to null, if this is the case, then what I need to get? I need to get L1 dot val. Okay, otherwise I need to get the 0. Okay, why this condition is, let me show you one thing. So what if my L1 is something like this, 4 5, and my L2 is something like this, 7 6 4 3 1. In this case, first what you are going to do, 4 plus 7 is 11, 1 here and 1 come here, and 5 plus 1 6, 6 plus 6 12, so 2 come here and 1 come here. So if there are no nodes, then let's take 0, because 0 plus something here, whatever here it is, it's going to be this value only, right? So that's a reason if there is no node, then let's take it as 0. So what we done, this is question mark by the way, yeah, and int val2 is equal to same condition, same applies for the L2 also. What if there are more nodes in L1 but less nodes in L2? So here also L2 dot val, otherwise take as 0. This is done. Now you need to have the updated sum value. Okay, let's take int sum is equals to val1 plus val2 plus carry. Okay, done. Now you need to update your carry and you need to update your sum. Okay, assume if your sum value is greater than 9, then you need to insert a node of sum only. I can tell you carry is equals to sum divided by 10. Okay, which will leave us what is the carry. I need to take it forward. Then sum is equal to sum modulus 10. And by the way, I said we are going to have some kernel node, right? Here, kernel node. So how you can going to take it? So for that, what I'm going to do here is list node result is equals to new list node of -1. Why I'm giving -1? I can tell you. The ranges of node value varies from 0 to 9 only. And I'm taking this extra dummy node, okay? Because initially my output is going to look like something this. -1 is going to be here only and its next is null. So whatever I'm going to get as a result of these two additions, then I'm going to add from here. And at the end, I'm going to return output here only. Assume if my head is this, I'm going to return head.next, so which is going to return my actual output. Okay, we are done. So next is take a cur pointer, list node, cur node is equal to point to the result. Okay, and what you need to do here is you are having now carry and sum. Now you need to create a node, okay, and you need to point kernode dot next to that, right? So how you can do here is kernode dot next is going to be new list node of sum. Okay, you created one node. Then you need to update the kernode pointer. Kernode is equals to kernode dot next. Now you are pretty much done with this. Now the thing here is every time, let's assume you are here, you visited 4, you visited 7. In order to go further, okay, in order to move further, you need to know whether the next value is null or not, right? So for that, what you need to do here is if L1 dot next is L1 dot next is not equal to null, then simply do L1 is equal to L1 dot next. Same applies to the L2 also here. L2, L2, done. So you're done with this case. Okay, now only the one case left. If you carefully observe in my this solution, okay. So here what I said, what if here it is 6 and it is 1, it is 4. 6 plus 1, 7 plus 4 is what? 11. So 1 I'm going to insert, but again 1 is going to be carry, right? And here after this visiting, there are no nodes in the L1, there are no nodes in the L2. But I need to create a node of this carry which is left, right? So for that, just check it. If carry is greater than 0, okay, then just do one thing. Kernode dot next is going to be new list node of carry and kernode node is equals to, actually we don't need this one here, but as a good practice let's maintain, and at the end just try to return your result dot next, because your result is starting from -1, okay, and you are inserting your node after -1, right? So just return result. Let's run it. Semicolon is expected. Okay, this is going to be question mark here because this is condition. what we are doing here is, so we are saying L1 dot next is not equal to null. So here if in case L1 is null, so we are going to have 0. Then L1 dot next is going to throw a null pointer exception, right? So we don't need to check L1 dot next. We need to check if L1 and L2 current pointers are not equal to null. Then you can go forward. Now let's give a try. Submit. Yeah, it got submitted successfully. And that's all for this video. And I hope you learned a new topic today. Please do subscribe to my channel. And I'm going to continue this series with few more important problems. And I'm going to provide valuable content in future. Thanks a lot.